So far, we have learned about the properties of normal distribution curves and how to identify them. In this lesson, we want to look at the standard normal distribution. A standard normal distribution is a normal distribution curve with a mean of 0 and a standard deviation of 1. This means the peak of the curve occurs at a mean of 0 and the data deviates from the mean at a rate of 1 standard deviation. The area under a standard normal distribution curve represents the probability and is always equal to 1. An important property of a standard normal distribution is that any normal distribution can be converted into a standard normal distribution. This process of conversion is called standardization. This allows us to take any normally distributed curve and standardize it, regardless of what the mean and standard deviation is. Notice the values along the horizontal axis. These are called the z-scores, and they indicate the number of standard deviations a data value is above or below the mean. A positive z-score means a data point is above the mean, while a negative z-score means a data point is below the mean. A z-score of 0 means the data point is exactly average. Z-scores are calculated by subtracting the population mean from an individual raw score and then dividing the difference by the population standard deviation. This is called the standardization formula and allows us to convert from a normal distribution to a standard normal distribution. From this formula, the z-score will be the main focus of our lesson. Z-scores are important because each z-score has a probability associated with it. In other words, we can calculate the area under the curve at each z-score point. For example, on a standard normal distribution, a z-score of 3 means that we are looking at the area under the curve from the left to a z-score of 3. This represents the entire curve, so the area is 1 and the probability is 100%. A z-score of 0 means that we are looking at the area under a curve from the left to a z-score of 0. This only represents half of the curve, so the area is 0.5 and the probability is 50%. To find the area or the probability of any z-score, we will use a z-score table, which looks like this. These values represent the area of the curve from the left of a z-score. Notice how we have one table for positive z values, which corresponds to the right of the mean, and a separate table for negative z values, which correspond to the left of the mean. The top row and first column represent the z values, and the numbers in the middle represent the area. To familiarize ourselves with these tables, let's have a look at an example. What is the area for a z-score of 1.6? The z-score is positive, so we go to the positive z-score table. The first two digits of the z-score are 1.6, so we find 1.6 in the first column. Since we don't have a third digit, we go to 0.00 in the top row, and we find its corresponding area. A z-score of 1.6 has an area of 0.9452, or a probability of 94.52%. To say this in a more mathematically correct way, we say the proportion of z less than 1.6 is 0.9452. Let's have a look at another example. What is the area for a z-score of negative 0.47? The z-score is negative, so we go to the negative table. The first two digits of the z-score are negative 0.4. So we find negative 0.4 in the first column. The third digit is 0.07. So we go to 0.07 in the top row and find the corresponding area. A z-score of negative 0.47 has an area of 0.3192, or a probability of 31.92%. And again, the more mathematically correct way to say this is the proportion of z less than negative 0.47 is 0.3192. We can also calculate the area to the right of any z value. Recall that area under a standard normal distribution is always 1. Therefore, the area to the right of a z value is 1 minus the area to the left. Let's try this as an example. What is the area to the right of a z-score of 2.66? We first need to find the area to the left of a z-score of 2.66. We use a positive table and find a z-score of 2.66. We can see the area to the left of this is 0.9961. To find the area to the right, we use the formula 1 minus area to the left. So we get 1 minus 0.9961, and our area to the right of 2.66 is 0.0039. Now let's try one last example, but this time it's going to be the reverse, where the area is given and we want to find the z-score. For example, what is a z-score with an area of 0.1401? First, we find the area on our table and locate its corresponding z values from the top row and first column. From the first column, we have negative 1.0, and from the top row, we have 0.08, meaning our z-score is negative 1.08.